11A and B, which are on reference angles and coterminal angles. This video continues the resources that we were looking at in section 1.1, which is drawing angles in standard position. So the first thing we need to do is define what we're going to be talking about. Now we're going to be talking about reference angles and coterminal angles. Reference angles for an angle in standard position, the reference angle is the positive acute angle between the terminal rotating side and the closest x-axis. This part is huge. It has to be the closest x-axis. It's a large point of confusion. It will continue to be as we move forward. So just remember, always to the closest x-axis, never to a y, because again, it's standardized. It always has to be the same, always to the x-axis. So basically what we're going to be doing is we're going to be drawing angles in standard position. So I'm just going to go through a number of examples to hope that we kind of pick it up along the way. So let's say I asked you to draw an angle of 165 degrees in standard position. First thing we need to remember is in standard position, our initial side goes on the positive x-axis. Our terminal side is going to be rotating in a positive direction, so it's going to be going up, the upward direction, 165 degrees. So we always need to be able to figure out what quadrant is that in. So you'll see that on this one, I drew 0, 90, 180, 270, and 360. That's the degrees that we'd go through if we went through a full rotation, just marking the angles that would fall at the edges of the quadrants. So I need to think 165 degrees is between which two of those? So I know that 165 is between 90 and 180. So my 165 degree angle must go over here someplace. And I want to show that it's rotated in a positive direction. So that's my angle. But to let my viewer know that this is 165 degrees without having that title of 165, I need to label the reference angle. The reference angle is, we said, between the terminal side, which is the side that rotated, and the closest x-axis. So that'd be this guy right here. That's my reference. You don't need to mark it with those pink hashes like I just did, but just to indicate that's the reference. What we're going to do is we're going to write the number, the measure of the angle in that location. So to get from 165 to 180, we'd have to go 15 more degrees. So the reference angle that I must label on my diagram is 15 degrees. Let's see if that kind of catches on. So my next one is 250 degrees. So again, it's a positive angle, so a positive rotation. So I'm starting on the positive x-axis and rotating in a positive direction. And I want to get to 250. So I didn't label the axis here, but I know that this is 180 and this is 270. So I must be somewhere over here with a positive rotation. Now it's close to the y-axis, but we said it has to go to the closest x-axis. So as a result, I need to think, what is the difference between 180 and 270? Because this right here represents my reference angle. So from 180 to 250, which is where we stopped, is how many degrees? So 250 minus 180 is 70. So in my diagram, I would write a little 70 degrees right there. That's its reference angle. Let's try another one. 322 degrees. So again, the positive angle. Start on the positive x-axis for my initial side, 322. So I know that at the bottom is 270, and once around is 360. So 322 must be somewhere in quadrant 4. With a positive rotation, so I show that it went all the way around to there. If this is 322, and again, the stuff in pink you don't need to be writing on your final answer. If this is 322, the reference angle takes me to the closest x-axis, so that right there is the reference angle. So the difference between 360 and 322, or 38 degrees, will be my reference angle. So let's see if we can keep going. 34 degrees. It's positive. It starts on the positive x-axis. 34 is between 0 and 9. So this angle is actually right in the first quadrant. So if this is 34, if this is 34 degrees, The reference angle takes us to the closest x-axis, so it'll be that guy there. So I need to say my rotation goes here, and this angle, the reference, is in fact the measure of the angle. That will happen for acute angles in quadrant 1. Okay, people like to generalize rules. They'll come up over time, but in quadrant 2, it's the difference between 180 and the angle. In quadrant 3, it's the difference between the angle and 180. In quadrant 4, it's the difference between 360 and the angle. And in quadrant 1, it's just the quadrant 1 angle itself. Let's see if I can make it a little bit harder. Let's say we look at 410 degrees. Now, we obviously recognize there's a problem here. 410 is obviously greater than 360. So this guy's gone around more than once. The question is, how much more than once has it gone around? So I would actually say that 410 is equivalent to 360 plus how much more? So 360 plus 50 degrees will give me 410. So my angle, which is positive, starts in the positive x-axis. It's gone around one full time and then 50 degrees more. So it's gone around one full time and then 50 degrees more. So the reference here is again just this angle. And that angle has a measure of 50 degrees. So we show angles bigger than 360 by rotating our spinner kind of around and out. So we create a spiral situation. Let's try the next one. The next one is negative 370 degrees. So in order to do negative 370 degrees, we need to go down. So this is negative, so it's going to go down. So again, I'm going to start on my positive x-axis, but before we start to think about where it is, we need to switch the direction of our labels. So if I'm going in the negative rotation this way, this is going to be negative or down 90 degrees. This would be down in a clockwise direction 180. This will be the negative 270, and then this will wind up at negative 360. So I've switched them because I'm in the negative downward direction. So now I'm thinking between which two does 135 fall? I'm ignoring the negatives, so that's just, again, just my direction. So I know 135 is smack dab between 90 and 180. And to show it as a negative spin, I'm going to show my spinner goes down with the arrow at the end. And again, my reference angle is this little bit. We said reference is positive. So it's the positive difference between 135 and 180. And I know that to be 45 degrees. So even though the angle is negative, the reference angle is always positive. And it's going to turn out that angles that have the same reference angles, angles with the same reference angles have some common properties that we'll see as we move forward. That's the end of reference angles. I'm now going to try to talk about this idea of coterminal angles. We're starting the same way. I'm going to graph each of these angles in standard position. So 110 is a positive angle. 110 is between 90 and 180. It rotates upwards. The reference angle is the difference between 180 and 110. That's the first angle. If I think about 470, again, it's too big. So I think about it as being 360 plus what? It's actually 360 plus 110. So when I draw it, it's going to look pretty much the same thing as the previous one. And this will be 70. But I need to show that this has gone around once and then 110. So in my spinner, I have to show that by creating that spiral. And the last one I have is negative 250. So again, I got to think of the negative direction. So this is negative 180. This is negative 270. So once again, my angle is going to fall 20 degrees short of negative 270, so it's going to go right there. To show the negative direction, I show the negative spinner up and around. And then I label my reference. I know that it's 20 degrees between the terminal and the y, but that means it's 70 between the terminal and the x. So if I look at these three pictures, they all look exactly the same except for one thing, and that's the spinner. So this is the concept of the coterminal angle. Angles that look exactly the same if it weren't for the direction or the number of rotations. So the definition for coterminal angles is angles with the same initial and terminal side locations that have traveled either in different directions or through a different number of rotations. So it could be or both. It could be and different direction and a different number of rotations as well. Because a rotation in degrees is 360 degrees, they're going to differ by 360 degrees. So we saw that here, right? 360 plus 110 is how we got that one. And I can actually do the same thing this last one, although I didn't think of it that way because it was within a rotation of 0. So, but this is the same thing as 110 minus 360. So I subtracted a rotation. So other examples of angles that are coterminal with 110. Any angle, if I add 360 to 110, that comes up with, and that will be 1. So we said 470, so 470 plus a rotation would give me another angle that's coterminal with it. So that'd be 770, 830. So 830 is coterminal with 110 and 470 and negative 250. Or negative 250 minus another 360 would give me another angle that's coterminal. So that's negative 610 degrees. That would also be coterminal with these. So that's the concept of drawing angles in standard position, including the reference angle, rotation, and the concept of coterminal angles. All these will be very important as we move forward.